Hi, I'm Adam Porter, and this is Programming Mobile Applications for Android Handheld Systems.
Today we're going to talk about the Android development environment, an integrated set of tools to help you create your own Android applications. In our last lesson, I introduced you to the Android platform itself. I talked about how the Android platform is a software stack for building and running mobile applications. And if you've used an Android device to write email, to take photos, to get directions, to play games, and so on, then you've seen the Android platform in action and you have a good idea about what it can do. So the next question then is, how do we use the Android platform to write our own Android apps? Well, one part of the answer is that you need to learn the details of the Android platform itself, and we'll do that throughout this class. Another part of the answer, though, is that you need to learn and master the tools that will allow you to make use of the platform in order to create those new applications. And that's what we're going to focus on today. Now, the tools that I'm talking about are called the Android development environment, and you should think of them as your workbench for creating Android applications. And like any skilled craftsperson, the more comfortable you are with your tools, the easier it's going to be to produce top quality work. Now, in this lesson, we'll cover several topics. First, I'll explain how you can set up your development environment, including installing the Android SDK, the Eclipse Integrated Development Environment, or IDE, and the Android developer tools. Then I'll show you the Eclipse IDE in action, and we'll create a very simple Android application. After that, I'll show you some specific tools, such as the Android emulator, which allow you to run Android applications without needing a physical device. And then I'll show you how to use the Eclipse debugger to help you diagnose any eventual problems that you might have in your application. And lastly, I'll show you a variety of other tools designed to help you further perfect your applications. Now, before you get started, make sure that you have a supported operating system. For Windows, these include Windows XP, Windows Vista, and Windows 7. For Mac, you'll need Mac OS X 10.58 or later, running on an Intel-based CPU. Several Linux distributions will work as well. Please see the Android developers website for more information. Now, you should also make sure that you have the Java Development Kit version 6, or the JDK 6, installed. And be aware that JDK 6 is not the latest version of Java. So some of you may have version 7, but that's not fully supported by Android. Again, check the following website for more information. So now we're ready to get started. So first, download and install the Android Developer Tools, or ADT bundle. Now, I suggest you do this right now, and that way you can follow along with my examples while you watch the rest of this lesson. You can find the ADT bundle at the URL shown here. Now, I'll also point out that Google has recently released a new IDE called Android Studio, which they expect will ultimately become the preferred IDE for doing Android development. However, since Android Studio is still currently in a preview or pre-release state, I'm going to do my demonstrations for this class using Eclipse. But you're free to use Eclipse or to use Android Studio as you wish. Now, the ADT bundle provides you with several things. First, it has the latest Android platform, including the latest libraries, reusable software, tools, and documentation. It also includes the Eclipse IDE and Android-specific plugins. It has additional tools that support developing, running, testing, and debugging your Android apps. And it has the latest system image for the emulator so that you can run and debug your Android applications without needing to have an actual device. In our last lesson, we talked about the Android platform. So today, we'll talk about the other three elements one by one. But before we do that, let's look at a very simple Android application called Hello Android. And I'll be referring back to this application throughout the lesson. Now, here I'm showing my phone's home screen. First, I'll click on the launcher icon, and then I'll click on the Hello Android icon to launch the application. The application starts and displays the words Hello World. Now that's about as simple as it gets, but let's walk through the process of writing the Hello Android application using the Eclipse IDE. Now this is the Eclipse IDE open to full screen. Let's start by creating a new Android application project. Now one way to do that is to go to the File menu, then New, and then select Android Application Project. Once you do this, you'll see a series of dialog boxes that ask you for information about this application. On the first screen, enter Hello Android, all one word, for the application name and for the project name. Where it asks for a package name, I'm using course.examples.helloandroid, but you can use something else if you'd like. Now go ahead and leave the other boxes alone and hit Next. Now for this exercise, let's just click through the next few screens. They control application characteristics that we haven't discussed yet, but we'll come back to them when the time is right. Once you arrive at the screen titled Blank Activity, go ahead and hit the Finish button. Eclipse will generate the application source code and layout files, and once it's finished, it will open a file called activity_main.xml. This file defines the application's user interface layout. And based on this file, Eclipse will show you whatever it can about how this application will look when it runs. As you can see here, Hello Android will display a simple screen with the words,
Hello World.
Let's also take a quick look at the source code for this application. Let's open up the file mainactivity.java. Now that opens up an editor window showing the contents of the file. And I won't talk too much about this source code right now, except to say that when this application runs, the onCreate method of this class will be called, and that code will set up and display the application's user interface screen. So let's run this code to see what happens. One way to run an application is to click on the project in the File pane, then select Run As, and then select Android Application. Now a dialog box pops up asking where to run the application. In this case, I only have my phone connected, so I'll choose that. And now we'll wait while the application is copied to the phone and then run. And there you have it, your first Android application running on a real device. Now, the phone I used is a Nexus 4. Let's suppose I'd like to test this out on a different phone. Let's say the Galaxy Nexus, but I don't have one of those phones. In that case, rather than run out and buy a Galaxy Nexus, I can run Hello Android on an emulated Galaxy Nexus using the Android emulator. And in order to do that, I first need to create the emulated phone instance that I'll use inside the emulator. Now, these emulated phone instances are called virtual devices. Let's go back to Eclipse and set up a virtual device corresponding to a Galaxy Nexus. So now we're back in Eclipse. First, I'll go up to the toolbar and launch the Android Virtual Device Manager. It might be a bit hard to see here, but look for the icon that shows an Android in a box. Clicking that will display a dialog box showing existing virtual devices and allowing you to make new ones. Let's click on the New button, which will bring up another dialog box. Under AVD name, or Android Virtual Device name, you can give this virtual device any name you want. Now go to the Device pull-down menu and select Galaxy Nexus. That will fill in a bunch of information for you, such as the target platform to use. In this case, let's use Android 4.2.2. I'm going to add some memory to the SD card, just in case we may need it later, and then I'll hit OK. You can see the virtual device you just created. Click on that, and then click Start. Now go ahead and click through the next screen, and then we'll need to wait several minutes while the virtual device boots up. I'll come back later when it's done. Okay, we're almost there. Just a few seconds more. And there's the home screen of an emulated Galaxy Nexus. Now that the Galaxy Nexus is running, let's return to Eclipse. And this time I'll install and run Hello Android on the emulated phone rather than on a physical device. So just like we did before, let's click on the project name, select Run As, and then select Android Application. A dialog box pops up showing us connected devices, and this time, instead of selecting an actual device, select the virtual device that you just started and click OK. Eclipse will install the application on the virtual device and then run it. And here you go, Hello Android, running on the emulator. Today I've shown you that you can build applications like Hello Android on an actual device, inside an emulator, or both. And there are pluses and minuses with each of these approaches. For example, the benefits of using an emulator include that the emulator is cheaper. You don't have to buy all the devices that you may want to test on. Also, unlike the phone, the emulator allows you to easily configure hardware characteristics, like the size of the SD card, the display size, whether the device has a trackball, and so on. Also, many modifications that you make, or any of the modifications that you make, are isolated to this emulated device. So you don't have to worry that your testing will mess up your phone or its data or configuration. Now, on the other hand, emulators have some downsides as well. For example, the Android emulator is pretty slow, and that can be frustrating when you're trying to rapidly experiment and tune your app, and you have to wait for the emulator to start up and run and shut down. Also, some features are not well supported by the emulator. For instance, there's no support for Bluetooth connectivity and no support for connecting accessories to the emulator via USB cables. Also, some software features aren't available by default in the emulator, so certain applications won't run on it. And finally, at the end of the day, the emulator is not a device. You can't know how your application is going to look and perform on an actual device just by seeing it on an emulator. Let's take a look at some of the advanced features that the emulator supports. For instance, you can configure the emulator to emulate the speed and latency of different cellular networks. You can configure the emulator to emulate different battery states, such as whether you're running low on battery power or currently charging the device. You can also inject mock location coordinates to make testing of location-aware applications much easier. And typically, these features help to test code that must respond to environment events. For instance, applications are often designed to do different things depending on the battery level. Let me show you how easy this is. Here I'm showing a terminal window and an emulator running on a virtual device. In the terminal window, I'll use Telnet to connect to the emulator. You can see the port number on which the emulator is listening in that emulator window's title bar. And in this case, that's 5554. So I'll type Telnet localhost 5554. Now I'll set the network characteristics to emulate a slower edge network. I'll type network speed edge. And notice that the cellular network status icon in the notification bar has now changed. Now I'll change it back to 3G network speed. And now I'll change the battery status to reflect a phone that is running out of battery power. I'll type in power capacity 5. And again, you can see that the battery status indicator in the notification bar has changed to reflect the lower battery level. Now I'll change the charging status to indicate that the phone is not plugged in. I'll type power status not charging. And again, as you can see, the battery status indicator no longer shows a lightning bolt and has changed color to indicate that the device is almost completely out of power. Also, if I open the Maps application, you can see that the emulator thinks that I'm currently somewhere near Washington, D.C. However, I can change that by inputting a new set of location coordinates like so. Geo, fix, 0.00,
40.00. And as you can see, the Maps application now shows that I've been transported somewhere near a beach in sunny Spain.
The Android emulator also allows you to emulate network interactions, such as receiving a phone call or an SMS message. Back in the terminal window, I'll reconnect to the emulator over Telnet. And then I'll give the emulator a command which will cause it to emulate an incoming SMS message. Now that command is SMS send, followed by the sender's phone number, 301-555-5555, and then the text message. In this case, this is a text message. Now keep your eye on the emulator window to see what happens when I hit return. And as you can see, the emulator's notification bar now contains a notification indicating that the emulated phone just received the SMS message. And we can pull down on the notification bar and then start the messaging application to get a closer look at that SMS message. Android also allows two emulators to interact with each other. Here I'm showing two emulator instances running. In one, I'll open the phone application and start to dial the number of the second. The number of the second emulator is the port number shown at the top of that emulator. In this case, 5554. Now you can see that the second emulator has received the call and is ringing its user. So I'll pick up the incoming call in the second emulator, and as you can see, now the first emulator's interface has changed to reflect that the call is connected. Now, if one of the parties hits the hold button, that will also be reflected in both phone applications. And once the users are done with the call, I can hang up one of the emulators, and both emulators show that the call has been disconnected. And of course, that's just a few of the many things that you can do with the emulator. There are many, many other interesting features as well. And if you want to know more, I recommend you take a look at the emulator page on the Android developers website.